In the name of Allah, the most gracious and the most merciful. Assalamu alaikum. Dear students, I hope you all will be fine. Today is 23rd April 2020 and the day is Wednesday. This lecture is for grade 7 and the subject is General Science. Students, I want you to open your General Science book and go to page number 116. I hope you will be on page number 116. In the front of you there would be a topic on the name of the ice and steam points. This is our topic for today and we will learn about the ice and steam points. But before going to this, let me remind you of the previous lecture what we have learned in this chapter. Currently we are in the chapter of effect of heat energy. In this chapter, we have learned about the basic concept of thermal expansion and contraction, in which we studied that when we give heat to certain materials, they expand. Why? Because the molecule in them, they goes from one another, and that's how it is. As a result, the material become expanded. When we cool down the temperature, the molecule in that material come close to one another, and as a result that material become contracted. The best apparatus to detect this contraction and expansion is a bimetallic strip. Bimetallic strip is made from two different materials. One is from iron and one is from brass. Okay, and these two different materials have their own thermal contraction and expansion temperature. It means to say that they expand and contract on different temperature from one another. Thermal expansion and contraction application is mainly used in our daily life. Thermometer is one of the example in which the mercury work on the basis of expansion and contraction by heat. Electric iron, alarm bell and engine vehicle also work on the application or the phenomenon of thermal expansion and contraction. Pendulum clock also work on this concept. Now the topic we are about to learn is the ice and steam points. Students, I want you to look to the first paragraph of this topic and let's see what it says. The Celsius scale, named after the Swedish astronomer Anders Celsius, is the temperature scale most commonly used in laboratory thermometer. It has two fixed points called ice point and steam point. In our daily life, you will have seen that when we are writing a temperature, we write this small c. This small c is called Celsius, and what this Celsius is, it is a symbol of temperature. It tells us about the temperature. For example, if you take test the temperature of someone, you need a thermometer, and with the help of that thermometer you can detect the temperature of a person. If a person has 36, for example, if that person has 36 degrees Celsius, let me write it. Okay, now if you write only 36, this 36 mean nothing, because 36 could be anything. Okay, it doesn't make any sense. But once you write with 36 this small c, then everyone will know that you are talking about temperature. Okay, so this Celsius, it is a scale, a temperature scale, and it was named after the Swedish astronomer Anders Celsius. Astronomers are those people who study about star, planet, okay, and other and the universe. Now if you look to the word temperature scale, what does it mean? You will have your own scale also which you use for mathematical works. For example, if you draw a line okay, and you want to know the length of that line. How we will know it? Just put a scale beside that line and you will know that the length of that line is 8 or 9, but that 8 or 9 need some unit, okay, and that unit may be inches or centimeter, okay, that could be centimeter, okay. Now as you write that 8 and after 8 you write centimeter, then we will know that you are talking about the length of someone. Same goes here with the Celsius. If you write Celsius with any figure, it means that you are talking about temperature. So that's why we use Celsius to refers to the unit of temperature, okay. Now in that line it also says that it has two fixed point and point called ice point and stream point. Let's look to it. What are they? Now if you look to the diagram which is given to us, the diagram is of thermometer, okay. In this diagram there are 2 points. The one point is called the lower fixed point and the other point is called the upper fixed point, okay. The lower fixed point temperature is 0 and the upper fixed point temperature is 100 degree Celsius. So first of all we will learn, let's first of all learn about the lower fixed point, what lower fixed point is. Look to the second paragraph of this topic. The lower fixed point or ice point on the Celsius scale is the melting point of pure ice at standard pressure. It is assigned the value of 0 degree Celsius. What does it mean? It means to say that the lower fixed point, which is also called the ice point, it is that point of the temperature at which the pure ice start melting, at which the pure ice start melting, okay, at which the pure ice start melting. And what is a standard pressure, I will just explain after this, but just for time being now, just remember standard pressure, it is the pressure of air molecule, okay, that is surrounding you. The air molecule that is surrounding you, they also produce pressure, that is called standard pressure. So at that pressure, okay, and at this temperature 0 degree Celsius, the pure ice start melting, okay, and it has given the value of 0 degree Celsius, okay. Now let's find out with the example of ice to detect the lower fixed point, or let's find out what lower fixed point mean, okay. Now look to this diagram. In this diagram it is also present in your book. In that page figure, look to figure 11.20, the ice point. This diagram is the same as that. Let's find out what lower fixed point is. Now lower fixed point we have to find, okay. So first of all I will take ice cubes. These are ice cubes, okay, and let's take a thermometer and put the thermometer between the ice. When I take this ice from the refrigerator, when I take it out from the refrigerator, at that time the temperature of this ice was -3 degree Celsius. It was -3 degrees Celsius, okay, and the temperature of the atmosphere or the surrounding where I was, it was 8 degrees Celsius, Okay, so outside the temperature, the surrounding temperature, it was warmer as compared to the ice, because the ice is -3 degrees Celsius and the surrounding temperature as 8 degrees Celsius. So it is a general rule that the heat basically it goes from a hot body toward a cool body. Okay, so in this case the hot body is 8 degrees Celsius and the cool body is -3 degrees Celsius. So what will happen according to that rule, the heat will start going from the surrounding temperature to the ice, and the ice will start absorbing that temperature. Once the ice start absorbing temperature, its temperature will rise from -3 to -2. Okay, but at this point the ice will be in that still that cube form, in that solid form. After some time the ice will absorb more heat and the temperature will reach to -1. At this point the ice will be still in that solid form, but when the temperature reached to 0 degree Celsius, at this point the ice cube will start melting. Okay, the ice cube will start melting. So at this particular temperature the ice start melting, it is changing its shape and it is converting into water, because we have seen on other temperature the ice cube was still remain in that solid form, in that cube form, but on this 0 degree Celsius the ice start melting. Okay, so that's why it is called the low fixed point or ice point. Why? Because there is no such other temperature at which the ice start converting into water or start melting except as 0 degree Celsius. Now look, now we will learn little more about the standard pressure, what standard pressure is. So standard pressure is also known as atmospheric pressure. Okay, it is also known as atmospheric pressure. Now what is it? It is force of air molecule per unit area against surface. Against surface it could be per unit area. Per unit area mean it could be anything, a part or area, any part or any area. Okay, let me make it more simple. Per unit area could be your room, could be your home, could be a bottle. Okay, it could be anything. Okay, a place or anything. So that per unit area there will have air molecules, and that air molecules will generate force against surface. Okay, most of the time it is producing pressure against the earth, the layer of the earth. Okay, so that pressure is called standard pressure. Look to the example. In this example they had given us a garden. Okay, and they have just only take this column of air, just only this one. Okay, this column of air. Now if you look to this column of air, there is air molecule. They have divided this into two portions, the first portion and the second portion. If you look to the second portion, there are more air molecules as compared to the first portion. Why? Because in this earth there is a force of gravity. We have a weight because due to gravity. The water has a weight because due to gravity. That's why air molecule also have weight. Okay, and when in this area, when the air molecule they are increased in the second portion, because the gravity is working on it and it is attracting these air molecule toward itself as more as possible. That's why when this air molecule is coming from upper portion to the lower portion, they are producing pressure. Okay, they are producing pressure. That pressure is called standard pressure or atmospheric pressure. Okay, with the help of this diagram we also know that when you are going to higher altitude, the atmospheric pressure will be low, and you are compared to the when you are go to the lower altitude. In other words, above the sea level, standard pressure is low as compared to those areas which are at sea level. I hope you will have understand it. Standard pressure, it is just simple that it is the pressure of air molecule, okay, and that pressure is due to gravity. Now let's learn the upper fixed point, what upper fixed point is. Now look to the third paragraph. Look in the book of this topic. It says that the upper fixed point or the steam point on the Celsius scale is the temperature of steam from water boiling at standard pressure. It is assigned the value of 100 degrees Celsius. It means to say that the upper fixed point, which is also called the steam point, which is also called the steam point, is that point of the temperature at which the water start boiling and start converting into steam. Mean to say that they are going from liquid form to the gaseous form at standard pressure, the pressure of the air at that area, and it has assigned the value of 100. Now let's find out with the help of this diagram how to find and how to know the upper fix or the steam point. Here I have a closed container, okay, and this closed container we have here water, okay, and there is just one opening where steam will come out once the temperature reach to the 100 degrees Celsius. And how I will know? With the help of this thermometer. Initially when I add the water, its temperature was 20 degrees Celsius, okay, and there was no steam coming out from that opening at this time. But once I start giving heat to this water, the temperature start rising. It rised from 20 degrees Celsius toward 30 degrees Celsius, then to 40, gradually to 50, 60, 70, 80, 90, 95. Even at 90 and 95, the water was still the man in liquid side, a liquid form, and there were no steam. But once it's reached to even at 99, there were no steam, okay, at 99 temperature there were also no steam. But once it's reached to the 100 degrees Celsius, I observe steam start coming out of this opening, and with the help of thermometer I saw that the temperature of this container is now 100 degrees Celsius. So I know that only at this 100 degrees Celsius the water is converting into gaseous form, or the water is converting into steam, okay, because I observed in all other at temperature 30, 40, 50, 60 the water was still remain, there was no steam. But once it reached to the 100 degrees Celsius, then I observe a steam, and that's why it is called steam point. Now the standard pressure would be in this closed container, okay, whatever the air in this closed container was, they produced pressure, and we will call it that standard pressure, okay. It has, that's why it has assigned the value of 100 degrees Celsius. I hope you will have understand this upper and lower fixed point. Now let's move forward, and students look to the last two line of that topic in the bottom of that page. It says that the temperature range between two fixed points is divided into 100 equal intervals, each interval being equal to 1 degree Celsius. Now what does that mean? Look to this diagram first. So the left one. what it says that the temperature has two fixed point. This diagram, it says that the temperature has two fixed point. The one is lower fixed point and the other is upper fixed point, and their temperature is 0 degrees Celsius and 100 degrees Celsius. But it doesn't mean that we just only have these two temperatures. No, there is a temperature between these 2 points, and that temperature is divided into 100 equal intervals, 100 equal part. In each interval, each part is equal to 1 degree Celsius. From 1 to 100, these all temperature are divided into 100 equal parts. Look to this diagram. The temperature here is from 0 to 10 degrees Celsius. If you're going from 0 to 10 degrees Celsius, there is a temperature between these 2 points. Okay, with the addition of 1 degree there, it will become 1 degree Celsius, then 2, 3, 4, 5, 6, 7, 8, 9. So each of these degree Celsius is the part of temperature, and this each interval is equal to 1 degree Celsius. Okay, now let's see the clock example. It is very good example. If the clock is going from 1 o'clock to the 2 o'clock, we will not say, or we can say that there is no time between the first hour and the second hour. If you look to the first hour and second hour, there is also time, but this time is divided into 60 part, and that each part of their time is equal to 1 minute. That's why we have 60 minutes in an hour. Same goes with here. In the thermometer, or in the temperature, we just not only have 0 and 100 degrees Celsius, we have more temperature, and that temperature is divided into 100 equal intervals, and each interval is equal to 1 degree Celsius. This is the end of this lecture. I hope you will have understanding better. Okay, I want you to revise this lecture, and and my homework for this lecture to you is that learn about the Celsius, what Celsius is, and what is the difference between upper fixed point and lower fixed point. The main point of this homework is that we have talked, or we have learned about degree Celsius, but there is also Fahrenheit in the thermometer and in temperature. So you have to find about and learn about Fahrenheit, what Fahrenheit is, and how we will compare Fahrenheit with the degree Celsius. Okay, thank you. Allah Hafiz.